right. Welcome to the stream, everybody. It's been 2 weeks, and in those 2 weeks, a lot's happened. Last week, my brother was visiting from Italy. Um, Wound up doing a bunch of stuff with my family. We went and saw like a local college football game. We hung out. We just did a lot of different things. It was a lot of fun. And then this week, I um, moved off of the Comcast ISP. Hey, Ole, welcome, and Michael and Johanderson. Um, and Michael, thank you for sharing everything. We'll probably pull your branch down and just take a look at what's going on. That's probably a good way to go. But yeah, got a new ISP. I'm on fiber. Um, and I should be about, well, my upload speed on Comcast was capped at 25 megabit. Um, so currently my upload speed is like 2 gigabit. So hopefully things are better. But yeah, the Argonauts are here. That's awesome. Oh, that's actually not a bad name for everybody. The uh, that was one of my favorite stories from being a kid. Just because he had the same name as me, Jason and the Argonauts. So I'm not opposed to calling people Argonauts, but and yeah, that's what we're going to get into today. It's some stuff that Michael has done. We're going to take a look at some work he's done, and then potentially come back to our then come back to our tour of heroes. But if we go take a look, I've got Michael's PR up right here, and I was honestly just thinking about going through the docs themselves, but Michael shared some stuff with me. We can run the demo, and we can take a look at the docs as they are from this branch. So let's go ahead and check out this branch, right? So let's go here. So all my pull requests. This is the branch we want. Just go ahead and grab this. Actually, I've got the GitHub CLI. Let's just see. Let's see if I've got it all configured. So let's go ahead and just paste that in. It may not like it. Oh, we're good. We're good. So where did that clone me to? So here we are. We're in the repository with the stuff from Michael's branch. We're gonna go ahead and yeah, with resources is really, really cool. But I'm just making the docs. I'm just making it so that everybody can understand what Manfred and Raynor did. That's all I'm doing. I'm just helping everybody understand the work of, the work of some other people who are highly talented and very intelligent. Nothing big, right? Just tiny things like that. But anyway, we're gonna pull his branch, and then he sent me some commands that I can take a look at. So So we can serve the demo and take a look at what the demo shows us, and then we can take a look at the docs. But the idea here, actually, let's take a look at the docs first. We'll take a look at the docs first, and then because I want to take a look at what we're getting and why we're getting it. Because as I was reading through this this morning while I was preparing for the stream, um, some of the stuff we were doing with the resources in our Sudoku game was wrong. And there's a good reason why it was wrong. So let's take a look at that. So we're going to do pnpm exec, and we're going to do nx serve. I need to. So it's nx run demo for docs start. Nx run docs start. This should start everything up for us. And if you guys want to, see this also, here's the link to the branch that we're using today. Okay, so first of all, I don't want it there. We're gonna grab it over here. We're gonna go pnpm. Why am I doing pnpm? We're gonna go localhost 3000. And that is going to serve the docs, the NGRX toolkit. Fascinating that this is a little bit different. So inside of here, we've got all sorts of docs, but what we want to take a look at is the extensions. And specifically, we're looking at the with mutation stuff. You got to put it on the homepage. Okay. Okay. So to get to it, let's see if we can figure it out. So with data service, so I'm curious if we can just do with mutations. Not found. Oh no. Let's go back and take a look at it's mutations. So let's try mutations this time. Not found. Did my checkout default to your branch? That's a good question. Let's take a look at my branch. No, I'm on main. Good point. Do I have lazy git installed? No. Git change. And then this should be, which branch is this? This branch. If we go take a look, Michael Small docs mutations. It helps if you spell it right. And it helps if you check out a branch. Is that the name of your branch? Let's see, get list. The get branch uh, list. I always forget my get commands. You know what? Here's the easier way to do it. Let's go to repo management and browse to a new repo. We're going to go dev ngrx toolkit. Select this folder. Here we go. So I've got, I created this. That's dumb. That is me being dumb. And so from my remote branch, I should be able to find my Michael Small. Where's your doc here? Oh, it's docs mutations. Okay. There we go. So we'll grab this branch. And we'll npm install this just to make sure that we get everything installed. And now we can npm exec nx run doc start. And there we go. So now our localhost 3000 should have the documents on it that we want. Uncaught runtime error. Oh, never mind. Never mind. So this is the stuff that Michael is documenting. So there's a way to do an HTTP mutation and RX mutation. Then there's also this notion of with mutations that can be added. What I want to do is go down to the very bottom. And maybe it's not at the very bottom. There was a piece on here. Yeah, it's in the background. So in the background, there's this piece where we talk about, well, not we, where they talk about why these pieces were put together. Because I'll tell you right now, I'm a big fan of immutable state. And these sound like we're doing something that violates immutable state, right? Why would we do it? And why not use the resource stuff to do this kind of stuff, right? So when we're talking about mutations here, we are talking about side effects. Mutations are typically side effects. Well, that's not true. That's not really true. What we're talking about here is we're talking about mutating the state. but we aren't talking about mutations in the classical form of mutations. We're talking about mutations more along the lines of things like TanStack query or Apollo, the Apollo client or things like that, where mutations aren't really, a side effect mutation of us actually mutating the object that's in the store. Mutations still follow proper. The mutations here refer more to us mutating something, and then potentially needing to update an API or something along those lines. These mutations are, well, it says right here, for handling methods like post, put, and delete, right? The Angular resource, and this is where we were running into problems with the resource that we were using in our Sudoku game. The Angular resource was really designed for just read operations, like an HTTP GET. Resources shouldn't be used for mutations. So they shouldn't be used to update some object, right? The resources should respond to updates to those objects, but they should not be handling those mutations. So the idea of the mutations key kit, of the mutations library, is based on a proposal from Marko Stanimirovic, which proposes a mutation API for Angular, and and it even goes into things like Angular query, but there are other things that have this notion of mutation where you can post and put, and then have your store react to those. So when we use mutations, we can pass them out on RxJS stream or on a signal stream. And then the nice thing about our signals is that they give us a value, a status, an error, pending, right? There's a bunch of stuff in here. It looks like we got status in here a couple of times. But has value, is pending, error, things like that, right? Those are important. And so that's what these with mutations are trying to do. I've got this notion soon that I want to do, and as soon as the signal forms move out of Next, I really wanted to jump into signal forms right away. There's a problem with signal forms, and that was called out earlier this week by the Angular team. And the problem with signal forms is that the demo that's out there that everybody's playing with relies on some hacks to the Angular core library, and they're working on, now that they've kind of vetted the signal forms API. They are working on making those hacks less hacks and more actual modifications to the Angular core. Once they have that figured out, I want to jump into signal forms, and I want to go back to our Angular dynos, and I want to dig into a couple of things. Since we've done Angular dynos, Zod has upgraded, and Zod has some really cool new upgrades. Signal forms will be a piece. These mutations here are going to be a piece of what we're going to do. And then there's another thing that I want to talk about that comes from DDD. I really want to talk a bit about value objects and what value objects are and why they benefit us. Yeah, exactly. The control directive has some issues because of the hacks that they put in place. Right, the hacks that are in place for the control directives, in the demo, like the thing is that they put this demo out there, and then it went to everybody, and then everybody's like, well, wait, it doesn't work because of all these other issues, right? Well, it was never intended to be a demo of the actual feature. It was intended to be a demo of what the feature could be like, to kind of give people the opportunity to um, the people to experiment with the API that they were proposing. Um, and it led to some angry feedback and broken, right, like, but this wasn't even like a pre-release alpha. This was like pre, right? It was just something that they wanted to get out there so that people could see it. um and so there's still some things that have to be figured out um before we can start, doing stuff with it. And I've I've gone in and I've played with the demo quite a bit. I'm excited for it, but one of the things I want to be careful about, um, and I feel like it's responsible of me to make sure that I'm not sending people to the Angular team angry, right? Especially for something like this that is, it's not even intended for public consumption. It was more intended to be like, hey, what if we did this, right? Unfortunately, um, all of us know that as soon as, like, if you go to like your sales department at work, right, or your project department, and you're like, hey, I was just experimenting and this isn't ready for anything, but check this idea out. And then the very next day that a client is suddenly wanting this, and they're building their whole platform around this feature that you demoed, and you had no intention. It was just like, hey, this could be cool. Um, so um, we just want to be careful there. But anyway, I'm way off topic. The the idea is, though, that we're going to take the Angular dynos, because that's our most forms heavy form, or our most forms heavy project. And we're going to do some work on that to make it better. We may do value objects before that. I'm not sure. There's another thing that, for whatever reason, I was watching. So I got sick this week, so I spent time watching a bunch of YouTube. I was watching. There's this AI game out there, and I don't even remember what it's called. But you basically start with the four elements: fire, earth, wind, and water. And then you can drag those elements onto each other. And then there's an LLM in the background that, when you drag them together, it creates a new object. And then you can essentially keep combining things infinitely. I wanted to see if I could build that in Angular. Um, so once we're finished with Tour of Heroes, I want to see if we can build that in Angular using something like, I don't know. We may, I don't know if we'll do Gemini or uh, ChatGPT or Claude, or um, what I'm really wondering, and this one might be fun, um, is I have access. Well, I pay for Featherless AI, and Featherless AI basically gives us access to every it's like every LLM that's available on Hugging Face. And so what I'm really curious about, is if we build that game, we get the game working. Um, I'm really curious about comparing like 1 billion parameter models to 3 billion parameter models to 5 billion to 7 billion to 9, 13, right? And see how the game goes based on different parameter models, and maybe even get into the differences between. So if you've been on Hugging Face, you know that Gemini is a big one there. Meta's um, Llama is another big one there. Claude is there. there's a couple of big model families that show up on Hugging Face but have been retrained. Um, and so I'm just really, really curious, just like from a one, can we build the game and make the game work? Two, um, if we build the game, can we make the game work in such a way that we can compare models um, through something like Featherless? I thought about like Hugging Face. Hugging Face is a little bit more expensive than Featherless, um, so um, I'm not sure about that yet. But um, a lot of future planning has been going on recently. But anyway, mutations, right? Um, the way to think about mutations are not the bad kind of mutations. These are the kinds of mutations that everybody needs in any kind of CRUD application, right? These are your updates and deletes. Those are where mutations fit in. And this is a nice way to provide mutations um, to our signal store, right? Because the NGRX toolkit works really, really well with signal store. But one thing to be aware of is we don't necessarily have to do mutations inside of a store. This is very, very similar to these two methods are very, very similar to like RX method and signal method from the signal store, NGRX signals, right? You'll encounter them quite a bit in a signal store or a signal state, but I use them quite often just by themselves inside of other classes, especially the RX method. It's really, really nice to be able to have a method that I can call that will kick off an RxJS observable chain that I can control. Same with signal, right? And it's really, really nice to have a function that I can pass a value into, an RxJS method into, things like that. That's the same with these mutations. So the notion behind Rx mutation and HTTP mutation is that these give you a method back that you can use and pass things in that will allow you to do the same things, but not necessarily having to go to like a full-blown signal store or a full-blown signal state, right? This increment method is going to provide some sort of mutation to the back end, where you don't have to have the entire state there. So you could have increment that then calls something, maybe it's a put, maybe it's an update, who knows what it is on the back end. Maybe it's a post, right? And so you can hit increment and be communicating with your backend and not have to have the entire state in place. That's the notion here. And Rx, HTTP, they're the same. Well, not the same. HTTP is specifically designed for HTTP calls, like I'm saying, put whatever. This mutation is designed for an observable stream. And of course, you can also put them inside of the with mutations that follows the signal store convention. And so you can see, hey, we've got this Rx mutation and things like that. We'll dig deeper into the mutations themselves, but it might help for us to just take a look at what we get if we run the demo. So let me go get the command to run the demo here. It's just a demo serve. Okay. So we can take this and we can just go demo serve. And this is going to run the demo that they put together to show off how these mutations work. So now we're back on 4200. We can come here. We can refresh this. And this is a bit bright. So let's turn on that. And oh, slash mutation. Okay. I was like, oh no, what's going on? Thank you, Michael. Okay. So here's our mutations. And I actually haven't played with this demo yet. So let's figure it out, right? Let's get our console up so we can see what's going on. So here, if we hit local increment, we can see that we're incrementing stuff here. Let's clear our network. So with the local, we're not incrementing anything. And it's showing that our value is incrementing here. We can see the results are coming in here. But now with the server in place, and one thing to notice here is that as we do this, we can see that the pending is set to true. The status goes to pending, right? And we don't have an error at all. So let's go take a look at the sending to server, right? So with sending to server, we get the same stuff here, but the server responds with a counter value. And we can see, hey, we sent this object to the server, right? And if we take a look at our network tab now, we can see that we're making this post to the server. So our post, so we're just posting to http://bin.org, right? And we can see, that we set all of this up. We can see our request headers. There are no cookies made, but we can see in our request, we sent this counter and the response came back with our headers, and the JSON that they sent back was basically the body that we sent in JSON, right? So we sent them this, they sent it right back. It's just an echo, right? And we can, we can take a look at all of this stuff, but we can see that we're getting, when we make this call, we're calling out to the server. And as we call out to the server, the server is responding, and we're getting back information from the server. So notice that we're sending the value here. So to change this, we got an error. So we can see, hey, we're handling errors here. We're going to go take a look at the code in this demo. We have to work on our small and medium screens. For now, it's fine. But notice that there's a random element to it that we managed to hit to show that, hey, you can hit errors, right? But here, now when we hit this, we're going to send the value 12 to the server. So these are both coming from the state, but this increment is local only. And this is sending the value from our local to the server, and then we're getting a response back. Yeah, the error message is, the bad luck error message is actually pretty good. But what I love about this, and this is important with a lot of the newer tools that we're getting. One of the very cool things about a resource, right? And specifically the HTTP resource, is one of the biggest issues we have and hitting this random error. Um, I don't know what the percentage chance is. We'll have to take a look at the code. But one of the biggest issues that we have when we get into HTTP is how inconsistent people are with handling the errors that come back, right? Um, and how many times have you seen a page break because something timed out? Man, I'm just not going to hit this. It must be pretty bad luck to hit it. The demo has /rx mutation. So we can also take a look at rx-mutation. So here we're not using the store, right? Oh, that's cool. Increment by 13. Oh, and we hit the bad luck. That's cool. Error due to bad luck, A2. And the result was 15, right? It should have been 15. We hit the bad luck. But the thing is, in a lot of applications, because we're very inconsistent in handling errors, we get into these bad states where the application is broken. And in a lot of cases, clicking this button would still be broken, right? But because, oh, it's always, okay. Increment by 13 is bad luck, right? 13, oh, the error is on 7 and 13. Ah, so it's not random. It's on 7 and 13. Okay. This one is just a way for us to trigger this error, which is really, really cool. I like that. And then sending to the server, right? We're just sending to pastebin. And this is pretty fast because it only has to do something when it's incremented, right? The reason it's so fast now is that it's probably going from my cache. But there's a lot of good stuff going on here. So the question is, like, what is going on here? What can we learn from it, and how can we apply it to what we're doing? Maybe one thing we can do is we can take a look at this demo, and we can update our forms for the Tour of Heroes. There was one thing I wanted to do with Tour of Heroes, and it might be a good time to do it now. I wanted to talk about value objects, and we're probably going to run out of time. Well, not really. We can take a look at the demo, and then we can take a look at Tour of Heroes. But what I wanted to talk about is this notion of value objects. And what I was thinking about was adding a phone number to our heroes, so that we could explore why a phone number is better served as a value object rather than as something else, like a string or a number, or who like any of the other ways, right? Like 3 fields of area code, country code, region code, number, stuff like that, right? Like there's so many different ways of doing phone numbers. But the best way to do it, as far as I'm concerned, is not to mirror the way it's stored, but instead provide a value object to the application. And so then you give a consistent interface to that phone number, to the application. So the demo is very cool. The docs are giving us good information. Let's go take a look at, that's not what I wanted. Let's go take a look at what we're getting, right? So if we look here, and let's just grab WebStorm and open this directory. So I just updated WebStorm to the latest version. It's just going to give us a README here. And in our apps, in our demo, um, so it looks like the one we want is this counter mutation. Hey, Abradores, welcome to the stream. I'm doing well, man. Is anyone using Zod on work? I saw people using it on back end mostly. Um, when I was at Bill, we used Zod quite a bit for a project that I put together. I don't know if they're still using it. There were people who didn't like it. The biggest argument they had against Zod was the package size. Um, they were complaining about the size of Zod, and then introducing like 200 KB packages to do like padding. And I don't. I'm being facetious here, but um, Zod did have a package size issue. With the latest update, Zod has lost that package size issue. The thing I like about Zod, and this is something that I bring up over and over again, is um, when you're when you use TypeScript, a lot of people think that TypeScript, right? If I take something and say I expect it to be an integer and I typecast it to as number or something like that, right? That has the potential to cause runtime issues. Because that MCP thing is also an interesting discussion that we can have. But the problem with TypeScript and ECMAScript, right, JavaScript, is it's a scripting language and it's not strongly typed. What does that mean? Well, that means that I can declare a variable JSON, and at one point I can assign a number to it. At another point, I can assign a string to it. At another point, I can make it null. At another point, I can make it undefined, right? Like the value of that variable JSON really, and I intentionally chose something that didn't have anything, right? That didn't communicate anything about the variable to anybody, right? I can make it an object. I can make it whatever, a Boolean, right? So when I typecast something, all of that type notation goes away. The only reason that you're typecasting to a number is because TypeScript is complaining at compile time. And so you're making that compile time issue go away. But TypeScript is correctly pointing you and saying, hey, there's a potential issue here. Libraries like Zod are important because libraries like Zod give you a way to write logic that you can use to parse something and get what you expect out of it. And if you don't get it, you can then do transformations. You can do, you can throw errors. You can do all sorts of different stuff, right? Like Zod is a way for you to handle that situation that we just talked about in a structured way. And the really cool thing about Zod is if you're using like Node on the back end, you can share those Zod parsers between the back end and front end, which is really, really cool. But there's other benefits in that you can use Zod to validate the data that comes from servers and use that same Zod parser to validate the data that you get from your users and use that same Zod parser to validate data that maybe you generate yourself, right? That Zod parser isn't just for that specific field. And this is where things like value objects and things like that come into play, because everybody who's ever worked on an enterprise level application knows that every damn phone number field in the entire application has validation attached to it, right? Some people are smart and they create a phone number validation that they attach to every field. Other people are smart and they create, maybe they're not smart and they add the same damn regex to every phone number field in the entire application, right? And they copy and paste that code over and over and over again so that in some places it's the old parsing, and in other places it's the new parsing, and sometimes you can't get to parts of your application because the parsing isn't consistent, and so now you have to tear apart the application. Like you may have heard from what I'm explaining that maybe I've been into type hell in enterprise level applications. How do we avoid stuff like that? Well, Zod's a good way. You can create a Zod phone number parser. Well, Zod has one built in, but you could create your own if you wanted. And then any place where you wanted to, you could then create a customer parser. And maybe in some places your customer needs extra fields, so you could extend that customer parser, and maybe a returning customer has extra information, so you extend the customer and you create a returning customer from it, and now you can validate that data everywhere using the same stuff. And if the phone number needs to update, you update your Zod parser for the phone number. And then everything magically works, right? It's a much better solution. And the nice thing is, and you guys have probably run into this too, where your validators for what's coming from the server are never as strict as the validators from what you get from the user, or the validators of what you're sending to the server. They're never that strict. And you guys probably work in perfect code bases. I haven't. And there are often times where we get something from the server, we trust it, and then the server decides to change. And in the past, it sent us a number, right? And so we've just always relied on it sending us a number. Our types are all written to be numbers. We've never validated or parsed or anything along those lines. Suddenly, somebody on the server's like, no, this would be better as a string. They change it to be a string. The response comes back as a string. The application doesn't catch that it's a string, but now you get weird behaviors. Maybe your form doesn't validate when loaded from the server. Because instead of sending a 0 like it did before, or a -1 like it did before, now it just sends an empty string for a field that doesn't have a value. And now your forms don't validate. A user comes in, grabs data from the server. They change their first name, right? Or maybe they change something, but they don't touch that field whose type changed when it came from the server. No, right? And then they get errors, and they don't know where the errors are. And maybe because it's on a hidden field, we can't figure out where the error is coming from. And you just get into this weird state. Zod helps to solve that, because now you can parse the data that comes from the server, and you go, hey, if they don't give me what I expect, put this in there, right? Or if I don't get what I expect, put an error up, or who knows what. And that's the real benefit of things like Zod. And I went way off on a rant there, but counter mutation is a dedicated store one. The counter arcs, awesome. Thank you for that. Been wanting to use Zod for stuff like CSV auto mapping of rows. Yeah. Exactly, Michael. Like CSV parsing is another great place where Zod comes in. Because you can take the entire CSV and feed it into Zod and have Zod parse it. And it's going to give you strongly typed objects in TypeScript. But beyond that, it gives you the ability to transform the data if, for whatever reason, the row isn't the right amount of columns, or who knows what, right? There's a whole bunch of power. Or legacy pre-TS front ends where we convert to TS and we find out that some weird JS non-type stuff. Exactly that, right? And you probably encountered the same stuff I'm ranting about, where the server changes types, or who knows, something's changed types, and it just really, really, really sucks, right? Or like the backend does a true validation parsing, but runtime bugs happen for various reasons. To be fair, even if front end sends bad data in validation on front ends. Yeah, and this is, so right now, So right now at work, I'm doing a lot less programming, and that's why you're like seeing me forget like Git commands and things like that. I'm not in the trenches doing coding right now. What I'm doing right now at work is zero trust, authorization, authentication. Um, I'm working with teams to help them design how we do zero trust situations, right? And in the case of zero trust, what we're looking to mitigate is one, we're looking to create more policy enforcement points. Um, so in a zero trust environment, you don't trust all the data, and oh, my mouse is way in the wrong place, but here we go. So like in a lot of applications, what happens is we've got the client, right, and then we've got the database here, um, and then we've got like our web server here, right, and our database gets the data here. Maybe it does some transformation here, and it sends it to the application. Well, the application assumes that this is all a trusted route, and so we don't enforce anything, right? When we come back, we introduce like a policy enforcement point here where we validate the data that we're sending. Um, there's another policy enforcement point here where we're like, hey, are you a proper user to be able to send this data, right? There's another policy enforcement point here where we probably validate the data. And in a lot of cases, there's policy enforcement points here on the database where we're looking at the fine-grained controls, right? Notice here, we've got 4 policy enforcement points. This is good. Unfortunately, we've got this route here from the database through the web server to the application, and we've got no policy enforcement points. We can't enforce that the data is good. We can't enforce that the user should be getting this data, right? Maybe we've got some policy enforcement points in the web server. This, the request was stopped here because of whatever reason. Who knows, right? Web applications, to Michael's point, could use a policy enforcement point here that says, hey, is the data I'm getting from the server even good? Right? And then maybe we've got our form here, but maybe we add a policy enforcement point here that says, hey, is the data I'm trying to stuff in this form even good? And then, we've got the typical policy enforcement point here that says, hey, I'm validating what was in the form, right? And then I'm validating what I'm sending to the server. But adding more of these policy enforcement points are important. The other thing that we can do at these policy enforcement points is if we segregate these points enough, we can control the blast radius. What we mean by that is we can control what happens with bad code at this point, right? Maybe my web server is compromised. Who knows? For whatever reason, and it's sending bad information that's trying to infect the clients in my local network, right? And this becomes a big deal in like big corporate places where if somebody can infect a local machine, and then that machine can start infecting other local machines, those become entry points for bad actors into a corporate environment. So if we can create a policy enforcement point here and potentially catch that, we can minimize the blast radius to, hey, maybe the application crashes, but the user's machine is not infected, right? And so there's a lot of these little enforcement points, and there is a cost here. Like, there's a cost to doing this. There's a cost to doing this. There's a cost to doing this. There's a cost to doing this, right? Every one of these policy enforcement points introduces a cost. What is that cost? Maybe that cost is time. Maybe that cost is network traffic. Maybe that cost is that we're increasing the amount of operations per second that we're making against the server, right? Maybe that cost is who knows what, right? Maybe that cost is really monetary. Maybe that cost is in lost customers because we've slowed down our application. Who knows what it is? But the other thing we have to realize is that we live in the real world, right? Um, and part of living in the real world is we have to evaluate, is this cost worth it, right? Is this cost worth it? Is this cost worth it? And this is where your value, especially in the age of AI and things like that, come into play. Being able to propose these, provide good cost estimates, and then provide good information as to, hey, this is still dangerous. If they put dangerous information in here, we don't want it making it all the way back to our servers, right? So yes, this cost is worth it. Maybe for the application that you're working on, this cost is not worth it, right? Maybe you don't have the traffic to, maybe you're not making enough to justify the upkeep of this cost, right? And these are the important things to think about. And this is what I spend a lot of my time doing, is analyzing all these different places where we could inject enforcement policies into our application, and what is the cost of that? Validbot is popular too, absolutely. But there are benefits to doing this. There are downsides to it also. But when it comes down to it, the other piece, as we think about applications, and especially web applications, front-end devs tend to think that the web page is the application. Back-end devs tend to think that the back-end, the APIs, are the application. The reality is the application is all of it. The back end is doing most of the state persistence, a lot of the state management, a lot of things like that, right? The front end is really reactive displays of the state that's persisted in the APIs. And then, because we're reactive, we're providing updates to the back end. That's the entire application. And you need to think holistically about your applications. When front-end devs get too powerful, we move too much of the transformation, the aggregation, and things like that into the front end. And maybe even too much of the validation winds up in the front end. When back-end devs get to be too powerful, right, then we move stuff that should be in the front end into the back end, and that's where you wind up writing like HTML parsers, because they want to store all of the template for your front end in the database, and right, like there's bad instances on both sides, and we need that balance. We need to think about the entire application holistically, and what is the cost of making this decision. You guys have all worked on the front end on bad back end implementations that are trying to feed HTML to the front end, and you know how painful that is. And the back end devs out there know that when all the aggregation and all of that stuff takes place in the front end, just how painful that is on the back end, especially in just like server load and just other weird stuff like that, right? That the front end devs aren't thinking about, because it's like, oh, I can hit that endpoint 10 million times a second. Well, no, you can't, and you shouldn't. So I don't know. What other options are out? Validbot is popular. Archetype, yep. Yeah, and there is a standard out there that Zod and Archetype and Validbot follow that Michael is pointing to. That will list, what other ones are out there. There are some that are a lot faster. There are some that work a lot better in React versus Angular. So Zod is my personal preference because it's the one I've worked with the longest, but it's also the one that works really, really well with Angular. there are others out there that are very popular because they work well with React or they work well with Vue, or so it really comes down to doing your research, looking up the standard, and then just deciding which one works for you. After trying to extract types out of doing DOM stuff, I realized front end is the most suspect part of a whole E to E flow. So you're 100% correct on that statement, Michael. And the reason is the closer you get to the user, the more you have to suspect the data. And especially in like web applications, right? HTML, you have to be very, very suspect of what's coming from your HTML, because anybody could take your HTML and modify it to make the browser behave differently. The other thing is they could write their own browser that is really just an application that takes your HTML, parses stuff out of it, sees where posts go and things like that, turns things into what they want and sends those back against your endpoints. And they're still sending the proper headers, and they're still appearing to be Chrome or Firefox or Opera, or who cares, right? They're just pretending to be a browser, and their browser is doing malicious stuff. That's not that common, but it is something that can happen. And I've written tools like that weren't intended to be malicious, but can be malicious, because the very first time I wrote a tool, I was hitting the web server like 10,000 times per second, which was an unintended consequence of how optimized we made the piece. It brought the web server down, right? So you never know. The closer you get to the user, you never know what the user is going to do. And if you look at things like monkey patching and fuzzing and chaos patching, and chaos monkey, and just go look up some of those terms. If you want to see like the crazy stuff that can happen to your application that you think is safe, right? One of the biggest discussions that I'm having right now with engineering teams is they're like, but the browser won't. I was like, we've got to get out of the thought of the browser. The browser's the way that you think about your application, but you're thinking about your application as being this perfectly pretty little flower that nobody's going to mess with. The way I have to think about your application is, hey, your application opens a door, and whoever wants to rush through that door is going to rush through that door. And so that's kind of the way to think about the front end of an application. And that's why we need back-end validation, why we need security, why we talk about things like policy enforcement points. Where can we enforce our policy on the traffic and prevent things from going through? If you ever go to like a highly secure government building, you know that the first checkpoint is usually the most difficult to pass, right? It's the checkpoint where you go through all the scanners and who knows what, but you may be moving through that government building and you may hit another checkpoint. That other checkpoint, depending on if you're going from, maybe it's a less secure access point in the front to a more secure access point, that secondary checkpoint may be more strict than the original checkpoint, right? And you may be required to provide biometrics like eye scans, fingerprints, hands, who knows what, as you're moving up in security. It should be the same with your application. There should be places where you enforce policy, but there should also be other places where you're like, hey, you're wandering around this, you're wandering around my application. Who are you? and we're going to enforce policy on you again. It's, it's just the notion of very high secure and keeping potential bad actors restricted to less dangerous areas, or even mitigating the potential threat. It's no longer if you get hacked, this could happen. It's now when you get hacked, what will happen? Especially with AI um, helping people exploit websites and helping people exploit things like that. So, totally agree with that statement, Michael. There is a lot of there's a lot of insecurity the closer you get to the user, um, and anything that you don't control, you shouldn't trust. Um, that's another that's another policy of zero trust, and even internally. So even if I'm hitting internal servers, but I don't control those internal servers, setting up policy enforcement sometimes is a good thing, because if somebody um, compromises your internal servers, your policy enforcement can help mitigate and keep that to just those internal servers. But again, this is where we start getting into um, cost benefit analysis type stuff, right? Where you're starting to look at, is the cost of me doing those internal policy enforcement worth the extra engineering, and what is the cost of us failing, and right there's a lot of analysis that goes into this kind of stuff. Anyway, we were talking about mutations today, so let's take a look at the store. So if we remember, and well, we don't need to remember. Why would we need to remember? Instead of doing that, let's go back and let's serve the demo. And so right now we're looking at the mutation demo. Let's go back to our browser, and let's go here, and let's just go to the mutation, not the RX mutation. So if we remember, this mutation, the store is handling this increment here, but it's also handling sending stuff to the server. So let's take a look at the store through that lens and just see what we can learn. So we've got this concat op. Let's see what we can learn about that. We've got an HTTP mutation, we've got an RX mutation, and we're using the with mutations. This tells us that we're using a signal store somewhere. These two can exist on their own, we know. And we'll learn what concat op does. I read about it, but I just want to be I want to do investigation, right? One thing to look at here, these params are actually very similar to a value object. Right, we've got a value of a number. These are the params. We'll figure out what this is for. And we've got another type where we're using the response that comes back from httpbin.org. It just echoes, right? We can see that here. And we were able to see that and figure that out by tracing the traffic and things. And that's one of the things that I recommend as you get more and more experience as an engineer. Learn how to do investigations, because you can figure this kind of stuff out without the comments there. And then when you're in reading the code, these comments validate the hypothesis that we formed, right? We hypothesized that this is what HTTP bin does. Now we're able to prove it by this code. So then we've also got our store, which is a classic signal store. This is written by Manfred, so I've got high hopes here. I'm expecting to learn a lot. Sorry about that. My throat is still a little bit itchy. Um, so this is our store. We're doing a provided in root. Um, I don't do this very often with my signal stores. Um, and this is something that I'm really looking at trying to figure out. Provided in root is an interesting concept um, because it works the same way as the provided in any of the decorators for the injectable decorator, right? That's basically what happens if we look at the signal store. This determines whether or not we use a provided in decorator on the injectable that's created for our store. I like my stores to go away when they're not needed. Provided in root is a global injector, and so that doesn't happen. And so I spend a lot of time thinking about, should I provide things in root? Should I provide them at the component level? Yeah, in tree by the store. But most of the time, root stores are reused a bunch but by beefier, 50% feature provided in. Yes. And that's correct. And that is the way I feel also, Michael, is something that's application level, I do provided in root. But I like to use a lot of smaller composable stores, and I like to use features to compose those stores from. Um, so I may have an application level store that's provided in root that uses the same features that maybe a local store that uses, right, the same features, the provide customer, provide, or not provide, but with customer, with whatever. And then I can give pieces of state from the store that exists forever to the smaller piece, allow it to do its thing, and then when it's done, it can disappear. All of the memory that it was using goes away for the form, but the global store sticks around. So anyone who uses a signal store could benefit reading the doc page of the component store, as it has a detailed breakdown of why not to default to root. And that's a good point. The component store was the predecessor to the signal store. And it had a lot of thought that went into it. It was solving an issue that NGRX had, where NGRX had to be global. And that's one of the things about providing in root. You're basically creating a global store again. So I'm not disagreeing with what Manfred chose here. What I'm pointing out is the internal struggle that I have every time I see something like this. Because to me, it's more of a struggle. And Manfred may be the same. I don't want to speak for him, and I don't want to call this out because it's just a demo. But what I do want to do is, when you guys are doing signal store, think about this. Think about if you need to provide it in root or not. And this is the benefit, right? So we've got the state that's got a counter and a last response. It's undefined as unknown or undefined. So we're setting the initial value to undefined, but this could be an unknown or undefined. This is fine, and I'm not calling this out. But what I would typically do in this case is I would do export, counter store or counter state, and this needs to be a type, right? Export type counter state, and it would equal. And this is where I would do counter is a number. And then last response would be my unknown or undefined. And then the other thing that I do is I wouldn't export this, but I would do a const. Um, well, yeah, we can do a const. Um, you know, counter state factory equals, and then here we can have a function that returns my object, right? And actually, yeah, this works. But here now I can do counter 0 and last response of undefined. And here, this is going to be a function that returns a counter state. And so here, my with state would just use my counter state factory. And this is the way I typically do it. And the reason I do this is personal preference. I like the state here because now I'm not having to do the as unknown or undefined. So I'm not having to add the type here. And this is entirely personal preference, but it allows me to see what a counter state is. And the other thing, I like this factory because having a factory is going to return, every time I call this, I'm going to get a new counter state. And so I can't mutate what the original counter state is. So if I want to do a reset, and I can just call this counter state factory, get back the default object, and that's going to reset my state. That's a big reason why I do these two things. They're personal preference, and I'm showing you my personal preference. What's here is not wrong, and it I just prefer this because I like to be composable with my stuff. I can use this in more places. I can compose more types from counter state and things like that. And I can even move counter state into another file, and I can have Zod validate my counter state for me, which means that then I can have a piece in my update where I use Zod to validate my counter state and make sure that my counter state hasn't changed. These are all personal preferences. The other thing that I want to just make sure that we're aware of is that this is a demo, right? So this may be here just to pull people away from like, well, why are we doing this? And more into we're using with mutations, right? So this is me being like, hey, I'm going to be pedantic here because I'm an engineer and being pedantic is what I'm good at. But I'm not by any stretch of the imagination saying that what was there before is wrong. And what I've done is the only way to do it or the correct way to do it. It's just personal preference. And I've built up reasons why I think my personal preference is correct, but it's still just personal preference. So if we look at this, we're now into our typical stuff, right? With mutations is very, very similar to something like with computed or with methods, right? It's just another signal store custom custom method that allows us to do stuff, or it's another signal store custom feature, not custom method, but custom feature that allows us to do stuff with the store. So we can see it takes the store as a parameter, and then it returns a function that does stuff with it, right? The increment is an Rx mutation, meaning this is not going to have an HTTP backend. It could have an HTTP backend, but it doesn't necessarily have to. It's just a way to mutate the store in a way that we can Well, we can see here, right? The Rx mutation is an operation. Oh, this is interesting. So we've got an operation here. We've got a concat map operator here. We've got an on success that patches. Oh, okay. This is cool. I like this. Yeah. Um, I agree with that, Michael. So anyone who uses signal store, yep, I would do that too. I see a lot of different libs, including NGRX ecosystem, do the as route for brevity, but I wouldn't omit a type up front in real code personally. And that's so this comes down to personal preference. It comes down to the way the code is written. Um, Whenever I come into a new project, I'm not going to do this. I'm going to be consistent with how we do it in the project. And there's a big reason for that. That consistency is the way we read our code. And if everybody writes code differently, that slows everybody down because when you go in and you edit a JSON file, right, and not JSON, but a file written by Jason personally, um, and Jason does it a certain way. Now you have to slow down and be like, oh yeah, this is how Jason does it, blah 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 blah, right? Um, and then I go in and I look at a Michael's file, right, and I'm like, oh yeah, Michael does this, and right, and then we go look at a Johanderson file, and we're like, oh yeah, Johanderson does it this way. We go look at an Abradores file, and we're like, oh yeah, Abradores does it this way. Everybody has to slow down and be like, oh yeah, I've got to remember the context of the person who's writing this. And maybe everybody hates the way Jason does it, right? And so that's another little bit of overhead here because now I've got to keep in the back of my head, oh, this Jason guy, the way he writes his code, I hate it. And that's just that little, thread running in the back of my head. I hate his code. I hate his code, right? Um, if we're consistent, then when we go into a file, we know, oh yeah, this file behaves this way, right? We always do things this way. Um, and that helps speed up the entire team. That makes the entire team comfortable with the way code's written. Consistency over personal preference. If your personal preference is that big of a deal, create an RFC, create an ADR, whatever your organization uses. Follow the path to get there. Allow everybody to have an input, and then be willing to follow whatever decision is made. Right? People may not want to follow your ADR. People may not want to follow your RFC, and it may not be ratified. And if it's not ratified, be consistent. That's always way more important than your personal, right? Your personal vendettas against, the as operator or whatever. Like your personal beliefs don't trump what the rest of the organization does. And if I don't know, we'll leave it there. So the Rx mutation has an operation. It uses an operator of concat op. On success, then we patch the state. So if this operation, this calc sum operation is successful, then we patch the state. Otherwise, we handle the error. And this is the benefit to something like with mutations. We've defined this increment operation. This increment operation uses a function that returns an observable number. So it handles this operation in a specific way. It uses a concat operator, which is a flattening operator. I'm willing to bet that this is like a concat map, so that if a new operation comes in, then we append the next operation to the end. So we handle the operations in order. There's probably a switch op, which would mean that if a new operator comes in, then we cancel the existing operator and switch over to the new operator, and things like that. That would be my guess. Let's go, instead of guessing, let's go take a look at the documentation and hope that it hasn't gone away. So there's the concat op. Callback available, mutation. So there's always an operation. And there will there doesn't always have to be something like that, right? So when there's a success, you can call things back with the results. When there's an error, with mutations or solo functions. Do we go into concat op here anyway? Concat op. So concat op is the default. Okay. So yeah, there are exhaust ops, merge ops, and switch ops, right? And these behave the same way, I'm sure, as concat map, exhaust map, merge map, and switch map. So if you're familiar with RxJS, right, concat map or concat op is just going to concat onto the end. We can leave it out because the concat op is the default. Exhaust op is different in that it's kind of the opposite of switch op. With exhaust op, you don't queue any new operations until the current operation is done, right? That's the way exhaust map works. Switch op is going to be different in that if there's an existing one, it's going to cancel it and switch to the new one. So these are the differences. With exhaust op, it's going to keep the existing one and cancel the new one. With switch op, it's going to cancel the existing and switch to the new one. And then merge and concat are similar with some small differences, right? Where they merge things together. Concat just adds it to the end. Merge guarantees that the order. That's the difference between concat and merge. There's a guaranteed order with merge. So back at the bottom, the very, very bottom. Ah, I don't have the server up, so it's like, hey, what are you doing? Rx is choosing between. Oh well, I think what I'm saying is correct, and correct me if I'm wrong on this one, Michael. But basically, he's being explicit with the concat operator here. Because it's the default, you could just as easily comment it out. But again, for the sake of a demo, you're going to want to show everything, right? The last point of the bottom. Oh, can be passed as switch op, switch map, merge op, merge map, concat. Okay. And by default, there we go. And it was even highlighted in purple for my find for me. I just chose to be ignorant. I chose to ignore it, I guess. But yeah, basically what we can see is that switch op is switch map, merge op is concat op, and exhaust op. The reason that I'm willing to bet these are named op instead of the actual names is to avoid naming collision, but also because these probably work on both signals and observables. And so they wanted to communicate that these aren't just observables, is my bet. I don't have any insight into that outside of that. So yeah, he's explicitly saying concat op. We could just as easily make this a merge op or a switch or an exhaust. When we're successful, then we patch the state, which is what we saw. This is a good question that happens right at the top, but isn't mentioned until the bottom. So I'll link to it or preface. That that would be helpful. But we can see here that in an error, that we don't patch the state. And this is the important thing about like resources and things like that, is that there is a way to handle errors. And if you handle errors, you can handle them in a consistent manner. If you don't handle errors, it's not a big deal. Things are going to keep working. You just aren't going to be able to hook in and handle the errors, right? Let's go take a look at CalcSum. So this just creates some observable, and create some observable. Here is, we're just returning a new observable. We've got to subscribe. Like this is the typical observable. So the result is just a simple addition. And then if the result equals 7 or 13, then we throw an error on the subscriber. Bad luck error. Otherwise, right. And that's why I couldn't get an error anymore. That's why I thought I was really, really unlucky. The other thing we could do is we could make a random generator here, and throw an error. So we're also just handling the error. Where is error declared? Oh, so we set the error outside of the create observable. And this is, we're just maintaining some state here. What this is allowing us to do is if we hit the result and we still got an error, we're not going to throw an error again. And we set the error back to false here. It's one way of doing this kind of stuff. It doesn't hurt. It's probably there's safety in this too. The nice thing about this is that this if statement has constrained result to being a number. That's why it's green. That's one of the things I really like about WebStorm is that when something can only be a certain type and you know it, WebStorm's going to let you know. Here, the type isn't guaranteed. We've said that A is a number and B is a number, and that's likely, but at runtime, it's not guaranteed that A is a number and B is a number. We could pass in a string and a number here, which this addition would then be, a concatenation. But because we're using triple equals here, this becomes a type guard. And essentially what it's saying is that it has to be the number 7 or it has to be the number 13. So this could be even more, this could be even more tightly scoped. And I have seen it become more tightly scoped in instances where it needs to be. But for this case, number is just as good. But having this variable in green means that you know for a fact this is a number based on a type guard somewhere earlier in the code. It can only be a number here. Notice the error doesn't become, it doesn't become scoped by the type guard. Even though it's declared as a Boolean, the language itself allows error to be changed to something else. So it's not necessarily a Boolean here. We're assigning a Boolean to it, but it hasn't been guaranteed by a type guard the same way that result has. And these are interesting things to know, or not even interesting. These are important things to know about JavaScript and TypeScript. You can do this kind of stuff is commonly referred to like duck typing, where you can narrow the type. This is type narrowing. These are type guards, type narrowing, duck typing. There's a lot of different names for it. But what we're essentially doing is we're using logic at runtime to narrow what the type can be, and that gives us better confidence in what the type is. And notice here, result is called a number, right? And result is a number here. But notice that result is not guaranteed to be a number here. The type system says, hey, it's most likely a number, but it's not guaranteed to be a number because we don't have this type guard in place. And because this type guard, this if statement says, hey, this is a number, then when we hit the else statement here, this else becomes it's not guaranteed to be a number, right? This is guaranteed to be a number. This else says it's not guaranteed to be a number because we know it's not 7 or 13, and we know that or we have an error, right? We know it's not 7 and it's not 13, or we have an error. But there's no guarantee that result here is a number outside of the constraints that TypeScript is putting on it. And so there's stuff that we can learn from our code that guarantee, like we're guaranteed that result is a number here. And we could even break this. Like one of the things that I was saying was we could say, hey, const rand chance equals math.random. And yeah, we could do kind of like a D10, right? Times 10. And then here, if we change this to say, hey, if rand chance is greater than 5 and we don't have an error, then get result. And notice now that result is no longer green, because even though result is declared to be a const, and even though TypeScript can infer that result is a number, at runtime, either one of these don't have to be a number. And this is again goes back to the discussion we had earlier, where say the server sends one of these as a number and the other one as a string for whatever reason, then this is not guaranteed to be a number, even though TypeScript can infer and say there's a high likelihood that it's a number. It's not guaranteed to be a number. However, with the type guard we had before, it was guaranteed to be a number because it had to be a 7 or a 13. Important things to understand about your code, and important things to understand about type systems and type checking. And this isn't unique to TypeScript, right? A lot of strongly typed, all strongly typed languages that have to work with dynamic data can infer what the data should be, but they can't guarantee that the data will be that, if that makes sense. It makes sense in my head, so it has to make sense to everybody else. But anyway, so we've made some small changes here to where now there's a 50% chance that that we get an error. I would actually probably make this like a 20% chance, or even a 1% or 10% chance, because you don't want to hit the error message all the time. And this is the nice thing about using something like this, is that we can control the chance of this happening, right? Say we want to get the error message a lot, we can make it a 90% chance. We can make it a 100% chance by just saying, hey, if it's less than 11, right? If it's less than 0, well, it's not possible to be less than 0, so there's a 0% chance. Just different ways that we can control how often we see errors and how buggy we want to make the system. These kinds of things I will typically put into methods like this, because we aren't going to want these methods at at runtime. So quite often when I'm creating things like this, they'll go into libraries that I can add that give me the ability to inject chaos into my system and see how my system recovers from chaos. But I do like the fact that we added this error here. So we're looking at the mutations. Save to server is an HTTP mutation. Again, notice here that the RX mutation is not mutating the store. We don't have to have any of this stuff here. This stuff is all optional. And it's not mutating the store. What an RX mutation is, and this is where, this is where it's important to be clear about the type of mutation here. This mutation is a side effect that's happening based on something that's happening in the store, right? So we're providing this increment function that's going to cause some sort of side effect mutation. But notice this mutation is not guaranteed to change the store. What it is guaranteed to do is whatever's in this operation. And all this operation does is return an observable with a value in it. For us to react to that observable, we have to use the success callback. And in that success callback, then we get the void, right? And here is where we're actually mutating, right? Changing the state. But this mutation should be thought more along the lines of like, Angular query, Apollo client, things like that, where the mutation is something that's going to affect something outside of our state. It's a side effect. And then we can react to that side effect. Same here with the save to server. It's a mutation. Oh, we do patch the state here. We patch the state with the last response. I was going to say that this doesn't have any mutation of the state. It does with the last response. And that's why last response is unknown, because they didn't want to provide types to it. And this is where this is a good call out. I like them using unknown here instead of any. Any is a great variable to use in libraries, especially where you want the typing system to infer stuff. Unknown is a much more strict form of any. And if you use unknown, it can't ever be anything but unknown. The only way to change the type is with a type guard that says, this unknown type, if it's this, then it's, an integer, or if it's this, then it's a string, or, right? We use type guards to convert from unknown. Any is a more permissive form of unknown. I prefer unknown in non-library code. In library code, any is a very valuable tool, but if you're adding any to your enterprise code, you're shooting yourself in the foot. Unless it's library code, you really shouldn't be using any. Unknown is a very good choice here, and I really like that. And the reason that we're using unknown is that we just want to throw the JSON in here. We don't really care about it. We're just going to display it. It doesn't really matter what the last response was. This is just to demonstrate that, hey, from an HTTP mutation, we can, in the onSuccess, patch our state again. But notice again that the HTTP mutation is very similar to like an Apollo client or something like that, where this mutation, it solely exists to call the URL, right? And it's using the post and all of this. We could have just as easily done this here. We could have just as easily used an HTTP client to do this, right? HTTP mutation is just removing a lot of the overhead, right? The boilerplate of doing this. So instead, we can use this, the HTTP mutation, and it's going to call the URL that we tell it, use the method. Notice that we're not using a get method here. This is definitely a post, right? We're setting up our body and our headers. And this could very easily come from someplace else. And this is where, like, when people, and I was on the wrong side of the fence here, and I'm changing the way that I think about things, specifically because of these mutations. Because I would say there's no reason that you can't do a post or a put or a delete in a resource. Sorry about that. I'm still getting over my cold. The Angular team says, no, you're wrong, Jason. Posts are only for reading. They're only for gets, right? An HTTP resource should only do a get. This allows us to do something like a resource in a much more controlled method. This Rx mutation here is what we're missing in the Sudoku game that I was trying to do with the resources. This is the right way to do it. What I was trying to do is wrong. And that's why we failed so miserably. Well, I failed. I'm not going to put this on you. I failed that one. It was an experiment. I failed. We'll go back and we'll fix it. And again, we've got our on success. Notice here that we aren't using the operator. We could put the operator in here, right? The operator could be a concat op, right? That's what it is, because it defaults to concat op. Does it? Before I say that, let's make sure. Let's go take a look at our HTTP operator. So saying concat op is the default. Let's look for operator here. Operator. So Rx takes optional wrapper of an Rx. Oh. I'm wrong here. We can't pass this operator. I'm not even sure what this does. Is this the case, Michael? Because we're saying that HTTP does not prevent race conditions using a flattening operator. The caller is responsible for handling concurrency. But yet I can pass in an operator here. Because one thing I would want to do is, depending on what the operation is, so like in a post operator, post operation here, I might go for an exhaust op, right? Because this is a good call. In the case of a delete, I would for sure have a concat op here. Because I don't want to be using like a switch map or an exhaust map. Merge map or concat map are probably okay, but with merge map, I would probably use a merge op here because I would want to guarantee the order, whereas with concat, I'm not guaranteed that. Yeah, because here, the save to server returns a mutation, and that save to server, if we go take a look at the code here and we take a look at save to server, the return type on save to server is a counter mutation. No, that's not it. So it is a mutation. So we've got a bunch of signals here, but what I don't want to do in my template is have to have an effect that turns a button on or off. I would rather have, because I'm already in RxJS land, I'd rather have just like a tap or something that allows me to get into that. And that's where I'm a little bit. So this is a promise. I guess you could do a dot then. So you could turn it off, save to server dot then. You could do that. Yeah, if you want the result, you can await a promise. Yeah, a hiccup of the root mutation model that Rx and HTTP. One thing I would like to understand is I think this is an important piece here. And the reason that I argue that it's an important piece is I would much rather control what's happening here. I would much rather control my race conditions here than here. And the reason for that is that if I put the race condition handling here, it's outside of my store, which means that now anybody who uses my store has to have that overhead of knowing that, hey, there's a potential race condition here and you need to handle it. Whereas if I can handle the race condition inside of here, then I'm encapsulating that issue and giving whoever's using it the ability to control it. The other thing that I'm curious about is like this operator concat op, right, is a flattening operator, which is an RxJS flattening operator. So our flattening operator has an RxJS flattening operator in it, which means that I could potentially create my own flattening operator if I felt the need to, for whatever reason. And then with my own flattening operator, I could do other things that maybe I needed to, like potentially interact with a web worker, who knows, right? Like whatever I wanted to do. I'm curious about that because that statement, I'm curious why this statement exists, why we can't use a flattening operator here. It just says it doesn't automatically prevent them using a flattening operator. It doesn't say that we can't do it. More curiosity here than anything, just feedback on that, Michael. But just from experience, the more we can encapsulate race conditions and handling of race conditions, that's why I really like the way this is set up, because the race condition handling is encapsulated inside of the mutation. The less that people have to learn when they come in and learn my code base, the more I can encapsulate code, the less that I'm forcing users to have to learn and have to remember, the less that I have to create like linting rules, the less that I have to push off on code reviewers and things like that. and the fewer mistakes, because people are going to make mistakes if we can't handle the race conditions here. And there might be a good reason why we're not handling race conditions, but there might be, I don't know. Some of these details were in the RFC. I should go look at the RFC. I didn't even look at LinkedIn until this morning when I agreed to look at this. So I'll go take a look at that RFC, Michael. Thank you for the feedback on that. I would recommend that you add those reasons to the documentation, because people are going to be like me and not go read the RFC. I found the bug in the type and will submit a PR, but I will also voice this up to the other guys. But I mean, I do feel strongly about this one. It is still a personal opinion, but just having worked with enough enterprise level code, knowing that things slip between the cracks, the more I can encapsulate, the more that I take the necessity, I call it overhead, like the cognitive overhead is what I call it in code. But what I mean by cognitive overhead, and as you move into like more platform roles and things like that, the less that somebody who's using my code has to think about, the better my code is, because their brains are going to be thinking about their deadlines. Their brains are going to be thinking about their logic. Their brains are going to be thinking about a whole bunch of other things. It's not guaranteed that they're thinking about race condition handling or things like that. So yeah. But this all makes sense. The class itself is just basically wiring all this stuff up, right? We inject the store here. Since it was provided in root, we don't have to have it as a provider. It could very easily be a provider here. Again, going back to the discussion before. So the counter method is here. The error is pending. All of this stuff is here. That we're setting up these signals. Right. The only thing we're doing here is we're adding this increment function, and then the save to server function. And then if we go take a look at the template, we can see, hey, here's our is pending, here's our status, here's our error. We can see that we're binding the increment to the click of this button, and we're disabling the button with the pending. This is one way to do it. The interesting thing here is I don't really think this is a big deal. And we can take this out. Like, I don't think it's a big deal here. If we go take a look at this code, right? There's nothing wrong with me clicking this like 20 times. So as I click this a bunch of times, there's really no downside to this, and the concat operator handles it just fine, right? I can click this 50 times. Where this becomes an issue is with the error. And what's interesting is we haven't hit, we're still hitting the 7 error. That's interesting. Did I not save? No, it's there. How low do I have that set? It's a 50-50 chance. I should be hitting that more often. That's interesting. So if we refresh this, it may be using the old code. So if we go, yeah, so 7 is, so 13, yeah. It, for whatever reason, it's not using my new code. I may have to stop the server and restart it because the store it is injected at root, and the way the hot module loading works may not be working. But we can see that there's really no reason for me to disable this increment button. there might be reasons to do it. Like you guys have all seen this where somebody hits a button, it doesn't go fast enough, so they click it like 50 times, right? I think that's what we're trying to prevent here, where we get the frustration click. And there's not a lot of need with an incrementing counter for that to happen. There is oops, that's not what I wanted. Let's not undo that. Let's go here. So this one's fine to be here or not be here. What happens here, and this is where you need to understand your audience and things like that. Let's pretend that like you've got like you're counting something, right? You've got a clicker that you're counting. And so maybe this UI is up on your phone and you want to press the button every time you see something to count. Maybe you're counting high number things. Well, that's interesting. It didn't pick up the change. This is where understanding your audience, though. With this button being disabled, you're basically preventing people from being able to count faster than this happens, right? With it not being disabled, they can click as fast as they want, and the increment keeps happening. So there, again, this goes back to kind of the domain-driven design of understanding your audience, understanding the use case, understanding the domain, things like that. Knowing, am I going to be going fast? Or is it okay if somebody waits for the button to become enabled again? So this is where, handling race conditions becomes important, and where you handle the race conditions becomes important. Sending to server is different, right? Sending to server, if you're not handling the race conditions, you may want that button to disable for whatever reason. Right, we're disabled now. This goes into another deeper discussion though too, and I actually need to end here soon, but one of the things to think about is you'll hear the word idempotent thrown around. And idempotent's just a fancy word for saying if you do the same thing with your API with the same values, you should get the same thing back, right? So if I post to, or if I do a put against a customer with JSON as the first name, then the first name should change to JSON no matter how many times I do that put. Same thing, like if I do a delete with customer ID 1234, every time I do a delete, it should only delete customer ID 1234. That's the notion of idempotent. You should be able to send the same thing over and over and over again, and the server should be able to handle it. And you shouldn't get weird results. If I send customer JSON 5 times, I shouldn't create 5 customers. I should get JSON created, and creating a customer is different, right? Because we could have 2 people named Jason for whatever reason. But idempotency is the reason that we're doing this. I mean, it's the reason that we would be disabling this button too, is that whatever we're communicating with is not idempotent. It's not going to guarantee the same results. And actually, this button right here is not idempotent, right? The number of times that I click it, I'm not going to get the same value over and over again. So this is not an idempotent function, but the function itself, we may want to be fast, right? from HTTP mutation, but the key committed is not type safe, so it was excluding operation, which is what operator used to be called. Okay, that makes sense. During my college Agile class, people found us not debouncing a button, so they booked 50 rideshare rides with a click before it was disabled too late. Don't get me started on spoofing that. Exactly, exactly. And this is understanding things like that, right? Understanding your audience in a clicker like this. The typical use case for an incrementer like this is, a counter. Um, some of the things that you might see counters like that in is like a pedometer, right? Like your watch, when it's counting steps, it's just a pedometer. And what it does is it senses, when it senses the motion uh, that typically is associated with you taking a step, it's just incrementing. It doesn't matter how fast you take your steps, right? You don't want a pedometer forcing you to look and be like, okay, now I can take my next step. Okay, now I can take my next step, right? That's not a good use case. Another place where like counters like this are used is in like produce, right? You might be counting how much produce flows past a conveyor belt and how much produce is kicked out by bad sensors, so that you can see what percentage of your produce is good versus bad, right? You don't want to have to stop the conveyor belt, right? Say we're moving apples along the conveyor belt. We don't want to scan one apple, wait a second, then allow the conveyor belt to move, scan an apple, wait a second, scan an apple, wait a second. Oh, this one's bad, kick it out. So now we wait a second. Okay, now we can move, right? That kind of stuff isn't a good user experience. You should probably debounce things and things like that. To Michael's point, you don't want people scheduling 50 ride shares. You don't want people, you don't want, on your concert ticket site, you don't want people ordering 100 tickets when, your max is 3 because they know they can click the button 100 times. It's knowing your audience, understanding your domain, understanding what needs to happen, and handling that. I'm usually not a fan of disabling buttons unless there's no other way to do it. I would prefer to use like my concat operators. One thing you could do is you could allow this button to be clicked over and over again, and that would be fine. But use an exhaust map, so they could click it 50 times, but until the first one's done, right? I don't know. But again, this is me. These are my personal preferences. These are how I like my UIs to behave. It could be different, and I recognize that. It comes down to more of the discussion about understand your audience, understand your domain, understand your use case, and then build to that, right? If you've got a bunch of people like my mom who double clicks every button she touches, she's going to get angry that, well, why can't I only increment by 1? Why does it only double increment, right? I've created a bad user experience for her because to her, everything you do on a computer is a double click. And as she gets older, she slows down the delay between double clicks. So she can keep double clicking everything, no matter how many times I tell her, Mom, you only need to click once. Mom, you only need to click once. Nope, everything's a double click. Doesn't matter what it is. Click on a link, it's a double click. Click on a button, it's a double click. Click on an icon, it's a double click. And so, right, in her use case, this, like what I just did here, is horrible. And so that's the bigger piece to take away from this, right? There is, as people, how much they've seen by, you're like, hey, should I do this? And they look at you for a bit and they go, that depends, right? As soon as somebody says, that depends, they've seen some shit. That they've been through it. And it's time to start discussing what the trade-offs are. So, yeah. Ole. I like to use exhaust map in most cases, and with signal store, it's really easy. You not always can add a spinner to all elements. Exactly. And you can't always stop a button. There's just there's a lot of good reasons to be able to use all of the operators and to understand all of the operators. And that's a good call out. Um, I typically use exhaust map on posts, puts, things like that. Deletes, you're going to get into a lot of trouble if you put exhaust maps on delete operators. That's just, I've put exhaust maps, I put switch maps. That only leads to pain. You should use either a concat map or a merge map on those. You don't want people losing deletes when they click something and switch map cancels it. Or you don't want people clicking a bunch of delete and three of them are lost because the first one hadn't finished yet. So again, it's understanding what you're doing, understanding your audience, understanding your domain. But I definitely need to end. One, my throat's still, I'm still recovering. I think I may have gotten the new strain of the C word. And so my lung capacity is still recovering from last week. I enjoyed today though. I really like this stuff. Thanks for sharing. Hey, Michael, you joined right at the end, brother. I'm glad to see you, man. I'm sorry I'm ending right now. I wish I could go longer just for you. Catch the bot. Thank you. I appreciate that. You guys have a great week. Have a great rest of your weekend, and we'll see you next Sunday when we're going to take everything we discussed today and we're going to put it into our tour of heroes because I really like this. Thanks again, Michael, for sharing. This was really good. It it was deeper than I thought it would be, and I really appreciate it. But that's what you expect from like Manfred and Rayner. There's a lot of thought that goes into this. I'll definitely have to go read the RFC. But yeah, you guys have a great weekend. I need to end this. We'll see you all next time.